Hello, everyone. Welcome. This is performance task for the week. It's called Two Wheels and a Belt. Went out on Google Classroom. It's going to be on your ELO assessment on Friday. So the difference between this problem and what you're going to see on Friday is that the numbers will change. Process is identical because the physical properties are identical. So let me run this by you. So you have two circles. One has a radius of 3, the other has a radius of 5. The distance between the centers of the circle is 14. And then these points where the belt, this is a belt that goes around the outside of these two wheels. This point right here, this point right here, this point here, and this here are all points of tangency. The overall goal is to find the length of the belt. So I'm going to label some parts here. I'm going to call this arc out here, the small arc. So to find the length of the belt, I'm going to have to find that length right there in red. Same thing on the other side here, only this is a bigger arc. Okay, so I have to find the length of that arc. And since these points are points of tangency, remember the properties of tangent is that they are 90 degrees to the center of the circle. And so all four angles here are 90 degrees. And then what's given is that you have 14. It's the distance between the two centers. So knowing that I have a tangent line up top here, these two shapes are a reflection of each other. So this top half of the circle is a mirror image of the bottom half of the circle, or the diagram rather. So if that's 90 degrees, all I'm going to do is sketch a line that is parallel to that tangent line that goes to the center of the small circle. So it looks roughly something like this. So if those are parallel, that means this is 90 degrees and so is this. And then since I also know that this is 3, the properties of this rectangle are such that this is 3 as well, opposite sides, which means this part here would be 2 because the radius is 5 and 3 leftover part is 2. And then I also know that that's 90 degrees because that's a straight line. So we're just going to call this line on the outside X, which is the same, like I said, mirror image down there, X. So working towards finding, first of all, X is, process would be to take this triangle in the middle. Remember, 14 is the distance between the two. So 14 is actually that line segment. So if I were to draw a sketch of that triangle that's in the center, a green triangle, talking about this triangle that I'm shading in, right there. The hypotenuse opposite the 90 degree angle is 14, and then the small side is 2. So to find X, which would be this side because it's a rectangle, opposite sides of a rectangle are congruent, I'm going to use Pythagorean theorem. So in other words, x squared plus 2 squared is equal to 14 squared. So then if I jump to my solution, well, actually, if I jump to the second to the last step, x would be the square root of 14 squared minus 2 squared. So the value of x is 13.86. Right? So that's an important part of the process. Second step, we're going to try to find the length of the bigger arc over here on the right, this arc. So remember, important formula, the length of an arc is equal to whatever the central angle is over 360 degrees times the circumference, or pi times the diameter. Now, in order to get this theta on the inside here, I need that central angle. So let's call that theta. The only way I could really get theta is if I know this small angle right here. Remember, this angle right here, let me just grab a different color here real quick. This angle right here is the same as this angle that we just worked with this in this triangle, and this is congruent to that. So if I take these two angles, subtract them from 360 degrees, I have theta. So I'm just going to call this angle Y. That's angle Y. Down here, to get that angle, which we're calling Y, I have to use trigonometry. And what I have to begin with is this side is the adjacent side as it relates to the angle, the reference angle, and this is a hypotenuse. So remember, with our acronym SOHCAHTOA, the adjacent and hypotenuse ratio is a cosine ratio. So I'm going to use the cosine of angle Y to try to find angle Y, and the ratio is the opposite, which is 2 over 14. There's my ratio. So when I want to find an angle, I'm going to use the inverse of the function. Okay, and you'll learn more about how this whole identity works in your next math class. But when you find an angle, you use the inverse of the function. So you're going to move that cosine to the other side of the equal sign, and it's going to change that to the inverse of the function. So you have 2 over 14. Okay, and then remember, in your calculator, it's super important to keep your calculator in degree mode. So then you enter this all in one step. Use the second key, cosine, inverse of cosine, 2 divided by 14, and you get your angle. This is roughly 81.8. So remember, we need 2 of those. So 2y is just this angle doubled, or 163.6. And that's in degrees. So this 2y represents 163.6 degrees. And then if I subtract that from 360, I get the other angle that I'm looking for, which is 196.4. Okay. Now, since these are parallel, these two lines, and these are parallel, that means this angle, central angle over here, is the same as the angle, central angle on this other circle. So that one's 163.6. So with that information, we're going to try to find the length of the large arc. So remember, the length of an arc is equal to the central angle, 196.4 over 360 times pi times the diameter, which is 10. So if we do all that, crunch our numbers, the length of that arc ends up being 17.1. So we've got that. Then if I jump to the other side here, I want to find the length of the small arc, same exact formula. Length equals, central angle is 163.6 over 360 times pi times 6. 6 is the diameter. So the length of that arc, small arc, is 8.6. So to find the total down here, you just add all of those parts up. So you have x plus x, which is 13.86 plus 13.86 plus the small length of the small arc, which we know is 8.6. Finally, plus the length of the large arc, which is 17.1, for a grand total of 53.4 units. Okay, so quick recap. Got your mirror image, tangent lines, point of tangency, create this triangle in the middle, find the length of x, which is not the hypotenuse, it's the long leg. Find the missing angle here using trigonometry. Subtract that from 3, or double it to get this other angle. Subtract that from 360 to get this central angle. All these are parallel, so they're the same. Okay. Find the lengths of the small and large arcs. Add them up. Okay, so I'll put that right there. Again, Friday, the radius is going to be different, and the distance between the circles are going to be different. Everything else, process included, will be the same.